Alright, so hello and welcome. Again, I'm going to keep my voice kind of low. I lost my voice. So, um, here we are. And this one is going to be the longest uncommon subsequence on LeetCode, C++ Medium. Let's give it a go. Hopefully I didn't mess up my streaming setup here. So, find LUS length, least uncommon subsequence. Given an array of strings, return the length of the longest uncommon subsequence between them. The longest uncommon subsequence does not exist, return -1. Oh yeah, I didn't actually come up with the solution to this yet, but I was thinking about it, so it's a very unusual kind of a question. Uncommon subsequence between an array of strings, a string that is a subsequence of one string but not the others. A subsequence of string S is a string that can be obtained after deleting any number of characters from S. For example, ABC is a subsequence of ABDC because you can delete the underlined characters in ABDC to get ABC. Other subsequences of ABDC include ABDC, AEB, and the empty string. Strings ABA, CDC, EAE, AAAA. So, strings between 2 and 500. Strings are 10 characters. They're all, excuse me, they're all lowercase English letters. Then the length of the longest in between them. So that is to say that first things first, if you have an uncommon subsequence. Oh yeah, actually I should lay down and think about this. I don't think I ever solved. I don't think I solved this one. I thought about it for some time, but then I thought about some other questions too. So, uncommon subsequence. Excuse me. So, the longest, if you take the longest strings, if there are any strings there that aren't equal to each other, then those are necessarily the longest uncommon subsequence, those strings themselves, because if suppose they weren't, then any of these strings would be a subsequence of some other string, either equal to that string or a longer string. But we said these are the longest strings. It can't be the longer string. We said there's no equal strings, so then it can't be that either. So it must be that this is it would be of the maximal length strings that are that are equal to each other. So we could find the maximal length of the strings, and then take all those strings and run them through all the sets that have that maximal length, and run them through a set and check and see an unordered set of strings and check and see if any of them are duplicates. Now, suppose for a moment that none of those maximal strings were the longest subsequence. Then we run into some issues, right? Because we could say maybe the next layer below, we can try the same routine and say, now the problem is the layer below could be of length values. It could be. The problem with this is that it could be the problem with this is that it could be. It's the same logic, right? If any of these are the longest, and they obviously if there are any duplicates, then those can't be uncommon, but any of those also could be the other issue. The other problem is that any of those could be subsequences of the duplicate strings that are longer, which would be quite awkward. Yeah. In which case, those are no longer uncommon subsequences. I think another approach to this is just to check if string A is a subsequence of string B. And then you can do a round robin. I think that's actually how I ended up solving this, or thinking to solve this, because it's a relatively small sample size that you're given, relatively small constraints. So I think you can just do a really simple basic check and just do a round robin. I think that's the way to go. 6 minutes in here, so excuse me. A string that is a subsequence of one string, not the others. What's interesting though is what if you have two strings? That's the longest uncommon subsequence, right? Yeah, I mean, the thing about that though is, I don't know, I would want to test a bunch of cases, I think. I think a round robin is fine. Uncommon subsequence. Subsequence of one string but not the others. The string itself, it would be a substring. I mean, unless there's if there's a duplicate somewhere else, then every subsequence of that string won't work. So really you can just check to see if there's a string, the longest string that doesn't match any other string. That's not a subsequence of any other string. I think that's it, really, the way to do it. Okay, so we'll do a subsequence B. Yeah, we'll just round robin here. Okay, so the tricky thing here is figuring out whether A is a subsequence of B is so A is smaller than B. if A is smaller than B, the tricky thing is that you would yeah, you could, this is fun. This is okay. Okay, yeah, I think I know what to do. Okay. I think it works out okay. My thinking is that you would want to, how are we doing? 10 minutes, 11 minutes? My thinking is that you'd want to take the first, for each character of, you could even do it this way. Well, that's fun. For each character in A, you want to see if you could find that same character in B from left to right in sequence. And you can always just take the first character you find that you need, I believe, because if there's another character later that might be better, excuse me, to take, it doesn't really matter, right? Or the sooner you find this character, the better, because you could always sort of, yeah, you don't really have any issue. Like if you take a later character, you only lose out on possible characters you might need to want to see or want to use. So we're gonna increment I, and then J we're gonna set inside the loop, and we'll just say as long as I is less than a.size. So we're gonna set character X equals a of I. I'm going to say while I guess if we make it through, turn true. So while b of j is not equal to x, we're going to increment j, and then j is less than b dot size. And we can also say, we just say if j is greater than or equal to b dot size, and then return false. Right, so we couldn't find this character that we're looking for. But if we do find this character, b of j is then equal to x, and then we would continue, we get the next character, and then now we would want to increment j also. That's a tricky thing, but so if we don't find this character, then we return false. But if we do find that character, then we increment j, and j could go over the edge. That's fine. Not a big deal. It really should actually at some point, but that should be the last character you look for, I guess. Excuse me. So round robin. Check that. Check any string is not a subsequence of any other string. If any such strings exist, part of the problem here too, by the way, is wondering, can you have a subsequence that's not the full string? No, because if there's a subsequence that's uncommon to the others, but is a subsequence of some other string, then that entire string should be not a subsequence of the others as well. Because if it were a larger string, then that means the smaller wouldn't be. So you could say it's always going to be the whole string. So we're going to say for int I equals 0, I is less strings dot size. equals I, j equals I plus 1, strings.size, and we're going to say const standard string reference A is strings of I, and same thing, B is strings of J, and we're going to say just bool check equals false, true rather. So actually it's going to be, we want all of these, we want A to be a subsequence of B. Yeah, we can do we could probably use something here and not have to use a raw loop. All of, let's try all of, and use a predicate. So, let's say standard algorithm somewhere as all of. All of, we're gonna say I plus 1, so it's gonna be begin plus I, and comp and compare is gonna be right, and we say, and then we'll say if all of, and actually that's going to be a dot size is greater than or equal to ret. And then ret is going to be a dot size. Return ret. Something like this. Something like this. Excuse me. Oh. Okay. Seems to work. How are we doing on time? 18 minutes. Okay. Wrong. Oh. What? Huh? That's confusing. What is going on? How do we get to, what? What? So confused. Hmm. Okay. Hmm. Oh. So it's not a subsequence of everything. Okay. That's a little bit better. I'm just utterly confused, by the way. Huh. Okay. Huh. Hmm. Okay. Let's give this a shot. So, I think I got the answer, but I run into some issues with debugging here. Hmm. Interesting. What? Is this just never getting called? Hello? Hello? Um. Yeah. But, but this is always what? Um. Hmm. This is just never true. I don't know. I guess the issue is that this gets converted to an unsigned. Maybe this is the problem. That could be it. Yeah, okay. Subsequence true, 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 true. Oh, that's confusing too. Oh, whoops. Is that as well? I see the problem. Couple of problems here. One is a integer to, let's see. Okay. Integer to unsigned into int check. And so the first one's correct. The second one is wrong. AAA is 1. So that's immediately right. This stops there. And then A. This is false. And I think it's, how does this work? This needs to not be a subsequence of all of these other strings. Excuse me. So this one stops here, and then you check this one against this one. A is not. Oh, I see. I got it wrong. I see the problem. Oh, that's awkward. That's very awkward. How do we just skip one of these in between here? Well, you could do something like this. I have an idea. There we go. So we want to skip I. Skip the string at I. There we go. That's what we're looking for. Now, this is kind of weird though. You can set this to, well, yeah, okay, that should be okay. We didn't really test anything else though. Now we're doing on time. 27 minutes. Wow. Well, that time for something we've already effectively solved. Let's see. There's got to be some test cases that I missed. There's got to be something I missed. Oh, well, we got it. Hey, 100%. I'll take it. All right, sweet. Go to the next one. Not bad. Yeah, I guess that's kind of it. All right. Nice. Not very quick programming that, but could have been faster. So thank you for watching. I will talk to you soon. Have a good rest of your day. Yeah, this was an interesting one. Yeah, like I said, I already thought about this for some time, but I didn't really come up with like a better answer, more efficient answer. All right, take care.